Hi, mentors and tech students. As it turns out, a lot of CS students have questions about what it's really like being a software engineer and things they may not know about or maybe possibly have misconceptions about. So, we're going to talk about 10 misconceptions about being a software engineer for college students. Over the past 3 years, students have given us a lot of feedback from mentorship and capstone projects as well during workshop and office hours. And it turns out a lot of students just don't know what they don't know, and maybe they have an image of what software engineering is really like, kind of set of skills they need, what they need to do. And turns out a lot of them and the reality being a software engineer is quite different. And this is also prompted by Mensur Dorovich's 10 hard to swallow truth they won't tell you about software engineering job. Definitely go read that at maybe as you read along with this or before or after, but definitely go get his take on it. And I would say we agree on a lot of it, but I have slightly different takes on it. So you might want to think about it as a lot of these things may be counterintuitive or doesn't quite gel with what you learned in school, but nonetheless are true in industry. And as always, I think at any job, how do you come across demonstrating technical competence, your commitment to the work, and then compatibility with the team? So all of the hard courses you've taken in computer science, whether it's algorithm, data structures, compilers, operating systems, isn't exactly what you do in software engineering. These courses and your degree have built a really solid foundation for the role, but the role is actually different than just what you learn in class. And Mensur is quite right. College will not prepare you for the job. I wouldn't say they didn't prepare for you, but it's a foundational preparation for what you need. And, you know, in software engineering, in work, you're going to build these new relationships you never had before. The previous relationship you had with professors or peers or at your college, your institution, and who you interact with is all going to be very, very different. For one, you're going to have a manager. A manager is not your parents, not your siblings, nobody related to you. They're not your professors. They're not your teachers. They're not your friends. So what is this new manager role that has so much influence on your work day in, day out? So figuring out what that manager relationship is really, really important. How to handle it is really, really important. The other thing is when you go to college, you pay the college, you pay a tuition. Here, it's reversed. The company pays you. So even that's a little bit different. And you're going to work with all sorts of different colleagues of different ages. Usually when you're in a class, everyone's kind of where they are in terms of age, but also experience that everyone's kind of taken the same courses, sequence of classes. Here, it's going to be really, really different. And you're also going to have colleagues that work with you either in your team or another team that your team is working with that are going to have very different roles and objectives. Usually, let's say the engineering school and the business school don't work together very much, but here you're going to have people in business, accounting, you're going to have all of these disciplines all with different objectives for what they want to do, all working together. So it's technically, it's also going to be harder. You're going to go into a company's tech stack. That's going to be different. So you're going to focus down into usually a narrower set of technology, and you have to get really good at it. So everything you learn in college has built a foundation for you, but it's not exactly the same. Mensur says you will rarely get a greenfield project. I think what you mean by greenfield is you own everything from design, just build something totally from scratch. On a real software engineering job, that's not going to be what it is. I'm going to say incredibly, incredibly, incredibly rarely are you going to be building something from scratch. You're usually building something that other people have built. You're building something on top of it. And on his blog, you can see like this really tall tower, and it's got a little bit rickety, and it's got a lot of things going on. Absolutely right. You are building not the whole puzzle. So you see a puzzle, you got so many pieces. You don't own the whole thing. You're building a piece of the puzzle, usually a feature, and you're building on an existing piece of software or a platform. You're adding something new. one of my managers when he worked at Microsoft, as an intern, he worked on PowerPoint, but he didn't build all of PowerPoint. He built a little feature that lets you like browse pictures, or like when you insert pictures, like a little gallery. He built that for PowerPoint. So you're going to be using something very, very similar. And what that means is you're going to have to understand what's going on overall with the software or the platform, your part in it, and how your part interacts with all of these other parts. Oh, is it going to back end? Is it doing, what's it doing? All of the touch points of what you're working on and how that affects everything else and how everything else affects you. So you're building something that's interconnected with a much larger picture, which for a lot of school projects, you don't get to do. And Mansoor here says, nobody gives a F about your clean code. I wouldn't say nobody cares. People do care, but to a certain extent. But I think what's most important is code documentation is way more important than you think. It's way more important than like a piece of clever code, right? You're not trying to show off to someone how clever you are. There's no contest of that. It's not the obfuscated C code contest or anything like that. You're not showing off here. So actually writing straightforward code that's well documented is much better than, doing something super, super clever that no one else will understand. And what you're doing here is that you're optimizing for understandability of others reading your code and trying to figure out what you're doing. And also maintainability. If you leave that job or you move on to something else, someone else has to come in and understand what you're trying to do and maintain the code, update it. And imagine like a future version of yourself coming in, and would they understand what you're trying to do with your code? And obviously, it's not like nobody cares about bad code. Why are you writing something that takes, n square time when you could do n log n, right? Or like nothing as obvious as, hey, you should be using, inheritance or anything instead of, copy and paste the same function over and over again, right? Which I've seen that in real work too. So as long as you're demonstrating you're pretty competent at it and doing straightforward things that everyone can understand, that is going to be what is actually people are going to think about being technically competent. Mansoor says, you will sometimes work with incompetent people. I don't think that's true in that sense. You're going to be working with a lot of other adult professionals, right? You're going to be interacting with a lot of different people with a lot of different backgrounds, a lot of different strengths, a lot of different roles, and they all have slightly different objectives. You'll be working with team or people on your feature team that are very aligned. They all know what you're doing. You know what they're doing. Your manager. There's like a smaller intermediate, a smaller team that you're going to be working pretty closely with most of the time. But then there's also bigger team, the bigger engineering team, doing something else you may or may not know. What seemed to you might be like, why did they make that decision? You may not have the context of why that is. Maybe there's a trade-off, right? That gets them something and that you may not know. I mean, engineering, after all, is all about limitations and trade-offs. So maybe they made some decisions, that trade-offs that works for one thing, but maybe adversely affects something else. So you don't know, but you need to communicate. That's really important. And then you're going to be working with even wider people outside of engineering, like marketing, product development, business development, accounting, support. That's a whole nother set of roles, a whole different set of priorities. So don't assume that immediately go to, hey, so-and-so's incompetent. It's they're doing a different job than you, and you really try to figure out what they're doing and what their priorities are. Sometimes everyone have really aligned missions and priorities and commitments, but sometimes one group's commitment or priority might be a little bit different than yours. And sometimes that, in engineering, that comes into conflict. And sometimes you do need to escalate to your manager or maybe your manager's manager. You work with your manager to get to your manager's manager together and say, hey, we're kind of, instead of, the big engineering team, kind of working in parallel, there might be some additional friction that we didn't know about. Maybe it's time for the higher ups to have a meeting and figure out what those engineering alignment should be. And above all, don't be a jerk. Nobody likes working with jerky people, so don't be that person. Well, the fifth one, we're halfway there, is be good at meetings. You're going to have a lot of meetings. I wouldn't say, some meetings you definitely need, right? Human beings work that way. We're just hardwired to have these face-to-face communication, teamwork, team building. That's what makes team work as human beings. And you get to understand what other teams are working on, what their priorities are, kind of what they're going to be doing, and also kind of what they're stuck, or so it's just a lot of just finding out. It's kind of like you're like a groundhog. You're once in a while you gotta poke your head up and see what's going on because you're so concentrated on what your and your immediate feature team is going on. And remember, this is also a time for people to get to know you and what you do. This is your time usually, at a ship room it's your public face to the team. That's how people will perceive you of, what you do, who you are as a person, who you are as a colleague, who you are as a professional. And sometimes, the big word, especially at bigger companies, is visibility, right? People will try to figure out what you're doing and if you're doing things well and you're being a good team player. And so, especially as a new grad, what you should do? Your manager knows how these meetings go, the personalities in the meetings. Prepare with your managers, prepare what you're going to say, especially at the beginning until you kind of get the hang of it, and have your manager help you out and say, hey, look, so-and-so is probably going to ask these type of questions, or the test team will probably have this, or maybe, the engineering team on this other side may have these kind of questions. And so you may have to defend your decision making and the reasons why, but only to a certain amount of depth, code reviews, et cetera, et cetera. So get good at those type of meetings. Make sure, it will become second nature to you after a few years, but it may seem hard at the beginning, but definitely work on it. It's something you need to practice and be good at. Yeah, one thing that I would say a lot of students have the most difficulty with is dealing with ambiguity and uncertainty. And Mansour says they will ask you for estimates a lot of times. And estimates come from a lot of different things. The official word here is swag. You'll hear people say swag. I think it used to come from the military a while ago, and it's essentially stands for scientific wild ass guess, right? You can go read it on Wikipedia where that came from. But it's essentially a combination of a few things, especially in software engineering. And there's a limit to how much information and how deep you currently know, but it's like, hey, let's build a car. Well, you had to, get metal, you had to build an engine, you had to tire, some of this stuff at a surface level or at a good enough level, but you don't know all of the details yet. So you're trying to figure out how difficult that is and maybe how long that'll take, right? So as to the best you can, how technically difficult is it? And then if it's a big project that's outside of your feature team, how much work is it coordinating with other team? And if other teams are taking care of this, right? You're making some assumptions. And then also your own experience or your manager's experience, and you give a swag estimate. And usually they're, in orders of magnitude. No one's asking, is it 4 or 5 days? That's not a swag estimate. That's like things you're saying, hey, this will take a week, a few weeks, a month, a few months, or we're talking about many, many months, right? So they're really they're trying to get an estimate, the order of magnitude, rather than this will take 17 hours and 40 minutes of my time to do, right? They're trying to figure out how big it is in orders of magnitude rather than a specific time. And as you learn more about the project, as you work on it, and as you kind of investigate and plan and design, these things change, and a good engineering team or good manager will know that and figure out how to communicate it to the rest of the team, and then also management as well. And it's always, I would say, safer to build in some cushioning as well. Mensur said 40%. And you'll figure out, depending on the team you're on, what that is. Sometimes you have dependability, you're dependent on other teams finishing this and hand it off to you, right? It's like a relay race. You can't go until you get that baton for whatever reason. Or you're working in parallel together and there's a joining together at some point, and you can't do it if their part's missing. So there's a lot of these assumptions, kind of project management kind of things that are going on. So things are ambiguous and uncertain, but you need to make the best of it and just kind of live with that uncertainty. And that's always going to be a part of software engineering as well as engineering in general. Yes, bugs will be your arch enemy for life. I wouldn't say arch enemy. Maybe it's just something that you have to live with. I think, Mensur is right. There's bugs will always be there because you're going to be building complex pieces of software, and complexity always begets more complexity and more bugs. That's just the fact of life. The more you build, the more things, the more pieces there are, the more likelihood there, errors. There's, I think, a few different kinds. One, there's like coding errors, right? Like, hey, I forgot an edge case or something like that. There's stuff like that, right? But there's also, I think, other things that you couldn't account for, or sometimes, really interestingly, it's not so much the software engineer, like it's not the coding that is wrong. Those are all done, that design was right, the coding implementation was right. Sometimes it's use case, right? You thought the user is going to use it like this, but they use it a totally different way. It's like, hey, we had a button here that does this. And they, customers may use it a totally different way, and that has unintended consequences and so on and so forth. So now you have to kind of redesign and, a part of your feature. Entirely possible as well. And some, because you have all of these bugs, you can't get to all of them all the time. As you fix one, something, it's moving forward. Your product is always moving forward. And so you always have to prioritize, how important is this bug? How many customers does it affect? Is that something that has a easy, take a swag estimate, right? Is it 1 week kind of fix, just a few days, or you can get it done in 1 day and you had to re-verify it, all sorts of stuff. And then sometimes customers will come in with a bug, and the hardest part is trying to figure out how to reproduce it. Maybe it's on a very specific machine, a very specific operating system under these conditions. Sometimes it takes a week to reproduce it, and then trying to figure out what it is when the fix is actually like an extra condition you put in, but super trivial. But finding it was actually the hard part, and not the actual fix itself. So you're always going to run into bugs, and that's just, you live with it, and you're always going to have a bug backlog, and you're always going to work on that as well. And so, yeah, that's just all part of software engineering. Kind of related to the swag estimates we mentioned earlier, Mensur on his blog says, uncertainty will be your toxic friend. I'm not sure it's toxic, but just like bugs, they're always going to be there. You're not going to have perfect information on everything, just like the real world. Everything, there is always ambiguity. There's, and in school, things are really certain, right? You have a homework problem set, numbers 1 through 10, you know how long it is, and you have a pretty good idea. The professor's already kind of scoped it for you. The test is going to be 2 hours. It's going to be from chapter 1 to chapter 10. And when the semester ends, that kind of, your AI class or your compiler class is over. Now you're moving on to something brand new, and you're kind of restarting again. So the real world of a software engineer is not like that. It's almost one continuous thing, and you're always going to have new inputs, new requirements, new things that, that needs to be built. And things are ambiguous, right? Like what the customer wants, what versus what they actually need, and what they're telling you, and things are always going to change. And you have to figure out, oh, this customer says this, other customer says that. What's the actual real answer? And sometimes there is no quote unquote answer, right? There is no true answer. So it's, decision that you have to make. And teams, which teams are you working with? People on teams come and go, and sometimes someone's working on this, and then like a month later they're working on something else. And so new people come in, people leave. So even just a team is not set in stone as well. Sometimes, there will be reorganizations, especially big companies. You'll have a brand new manager in a brand new group. How do you handle that? How do you settle in, right? Like you spent 2 years working on this project, all of a sudden now you're on another team in a different building. How do you settle in? How do you find your place? And so there's a lot of uncertainty just sort of professionally sometimes as well. And things are just ambiguous, right? You're never going to get the full picture. And sometimes just the direction of the product also changes, right? You think, hey, we're building this product for this thing and we're going straight. And then sometimes, upper management say, hey, we want to take this product in a new direction. You've seen it all the time, right? Or maybe that direction, or got to pivot. And all of these things produces ambiguity as well as change, and that could be just a source of stress for you as well, and the role you play in it. But so you'll always just have to know these things will happen, and kind of, I wouldn't say predict it, but at least be able to manage it well in your day-to-day work as a software engineer. Yeah, and all of these other things that we mentioned is true of most jobs, and obviously has its own take on, in software engineering. And Mansur said, it'll be almost impossible to disconnect from your job. And I think how you view it and everyone's limits is a little bit different. So how you view it, and also just the stage in your career and your life as well. So figure out how to manage yourself, right? Like a job can be all consuming if you let it, especially as a new grad. Like you got this brand new job and it's your first time working in that environment or a new company or whatever. So it could be all consuming. You're like, that's the most important thing in the world. And you kind of move from one crisis or one important meeting or something else to another. Everything seems to be like the most important thing that could be happening right now, and it needs attention now and generates a lot of stress. You do need to kind of pick and choose your battles. Sometimes crunch is unavoidable, especially in certain industries. Yeah, like Christmas, the product has to come out by a certain time before Christmas, and that's when all the revenue comes in. So you do need to pick and choose your battles, and just let some things go. You don't have to be right and be for everything. Sometimes you just kind of need to let a few things go. And, as human beings, we all think we are the main characters in our own movie, but that's just in your mind. People are, what you thought was like the most amazing, important thing you accomplished. Other people might just be like, oh, they did a good job. Or sometimes, to them, because, you prevented maybe a major disaster or something, to them, in a movie, you prevent disaster. There's a parade, all of these things. But sometimes in work life, it's like no news is good news. Or maybe they're just, the day just went by, right? Like, so just figure out how to manage yourself, your time, your stress level, and don't get burnt out. There's definitely a lot of cases of people getting burnt out in tech. So manage yourself, take those breaks. As a new grad, a lot of times, especially if you move for a job, sometimes you'll just have that circle of friends on your team that are maybe the same age or whatever. Definitely have friends outside of your immediate team. Don't only be friends with the folks in that immediate team. Yeah, it's totally fine to have, folks that are friends that are at your company. If it's a big company, and but in other departments or other divisions, and definitely definitely have hobbies that you can sort of put your mind into something else to drill down into. So it's not always work, work, work. And so managing that stress, managing that work, managing your time is going to be really important to prevent burnout and make sure that you're successful. It's, it's not a sprint, it's a marathon, right? And as a software engineer, echoing back to the first few slides, is that you will need to build up your durable and professional skills. Mentor says you will profit more from good soft skills than good technical skills. In a way, that's true, right? Like you got to be technically competent, but to a certain point. But you can't be, a jerk, a big jerk, right? Like, so not being a jerk and being technically pretty darn good is always, every team is going to take that person rather than like someone who's absolutely brilliant, but just no one wants to be around, right? So think about that, right? And as long as you are, whatever your level, experience, your role is, you need to be at a certain technical level. But once you're at that technical baseline level, all of these other things are, being a teammate, how to be a good teammate, how to communicate, how to manage up, work with your manager, managing your career, like the previous slide, kind of managing yourself, managing stress, all of these other things, just like how do you be a good employee, a good team member, and making sure that you come off as a likable person that people want to work with. And there's a set of professional skills. People call them soft skills, durable skills, but in any professional environment that you would need. So pay attention to those, and you'll see yourself kind of start using some of the language and things like that, but they do serve a purpose. And so this is all about being, I would say, compatible with a team. So if you move from, to a new job, you want to be compatible with that team. Or if you go interview for a new job, you want to come off as being, someone they would like to have on the team. So yeah, conclusion, software, it is a job that, as your first job could lead to a very high paying and in demand career. And in a way, it is high paying and in demand because it is hard, right? Like you went through 4 years of school to get here, lots of, difficult problem sets, really hard reading, a lot of tests and exams, and then also not to mention big projects and things like that to get to where you are. And it's, tech has a high bar of entry, just like a lot of other high paying professions. But, I think relatively speaking, you don't have to do additional years like med school or law school or business school to get into some of these things. And so it's actually pretty great way to get started. And the set of tools and skills that you'll learn from being a software engineer could actually open up a lot of future possibilities. You don't have to stay and be a software engineer forever. And if you do, you have chances to move up to be a lead, if you would like to manage people, engineering manager, and so on and so forth. Or if you want to be an individual contributor, you can become an architect and things like that. So there's a lot of progression within the field or the role itself. But you also have chance to stay in that role or similar role and go into a lot of different verticals and industries, right? If you're interested in clean energy needs software engineers for sure. Or in retail, or in automotive, in sports, whatever industry or vertical you can think of, all need computer scientists, all need software engineers. So it can open up a lot of different directions for what you want to do. And there's also within software engineer or maybe because of software engineering, there's a lot of related roles that you can do, right? You can go into things like sales, right? Somebody has to sell your software, your platform. You can become a sales engineer. You can also do things like software reliability engineer. You can go into marketing. You can go into business development. You can go into so many different roles. You can become a technical writer, right? Like, so just sort of, there's so many different adjacent roles next to software engineer that you can specialize in, and you can definitely play to your strength in whichever area that you want to go into as well. And of course, you can also work for a lot of different types of companies. You can work for startups on one end. You can even start your own business, right? And then on the other end, you can work for some of the most household names in tech, the Microsofts and the Apples of the world and Google that everyone will know. And then there's, Fortune 500 companies, mid-sized companies, family firms, companies that will let you work remotely as you travel and stuff like that. So there's just tons and tons of possibilities. And, within these three, you can mix and match and you can figure out what you want to do. And honestly, you never know where you're going to end up. And so, yeah, thanks for joining me on this. I think it went a little bit longer than I thought, going through the 10 things, but spending a couple of minutes on each. And so if you're an experienced software engineer, any sort of advice, please do comment. Or if you're a student or a new grad, you have questions, post there as well. And we also will put the link to Mansour's original article in the description as well. And so, yeah, it'll be really interesting. You'll never know where you're going to end up, and it's always a fun journey.